Okay, this is a continuation from part 4. This is right where we left off. So I just came off of this irregular rectangles page. This next one I want you to do. I'm not going to do the problem in class. I just wanted to point this out because one of the most recent tricks added to the math test on the actual TEAS is where they give you a picture that literally looks like this. It's a basketball court. And they ask you for the area of the court. And it looks like, because they have all these dimensions written in for circles and half circles and all kinds of things. So it looks like it's a really difficult problem and it scares certain people. But when you read the question, just like is very important in every aspect of math, you want to make sure you're zoning into what they're actually looking for. What they're looking for is the area of the whole court. The whole court is just a giant rectangle, and you'll see that they have rectangle sides labeled. So don't be frightened by that, and that's a good lesson for a lot of other things that they do on the test. I try my best to warn you all throughout my classes and curriculum of all these things that could happen, but just keep in mind they can always put info in a question and have it be irrelevant and try to throw you off by having the info be irrelevant. They can always put a bunch of things in there that make something look a lot harder than it is, as is the case with that one. So just be confident in yourself and in your strategies. Certainly coming through my program, you should have every ounce of confidence that you have seen everything you need to see, practiced everything you need to practice. And because of that, you should have a disposition of assuming they're just trying to make it look hard, but that you know how to do it. So it goes a long way to take a position of, I'm sure this is an easy problem that I totally know how to do, and there's just a bunch of extra stuff in here. Taking that position by default instead of taking the position of being scared or worried that you're going to see something you haven't seen, that goes a long way. That's probably the most important thing. So keep in mind, especially if you're doing this class right now, you are so well positioned to succeed with your math test that it's ridiculous. It's once you complete this class, you absolutely know what to expect in every corner. So assume that they have decoys there, assume they have extra info, or they have something that's made to make it look harder. They have something that's made to where the problem is longer. Anytime a problem is a lot longer, it makes it seem a lot harder. Kind of like what we did yesterday with the metric to American and American to metric. There's so many steps in that it seems really hard, and you naturally assume that you don't remember every single thing you should remember. And because of that, it's going to be a lot harder. So just keep in mind, you know all the processes. It really helps to play out the process right up front. Here's all the things I'm going to need to do. Metric is a great example of that. Even go back to that metric right at the end of the metric video, probably the last 15 minutes. We practiced with, okay, so I'm going to use the flow chart. I'm going to use it all the way from left to right. And then when I get to this place on the right, I'm going to have a 2-step metric to metric problem because I'm going from centimeter to millimeter. So just looking from above before you ever start the problem and just saying, here's the 2 steps I'm going to have to take, or here's the 10 steps that I'm going to have to take, and playing those out and then filling them in goes a long way on looking and feeling like you're confident. Circles. So you need to know how to do a circumference and area for any given circle. Again, just like with the previous page, add in area. I don't know why so many people make worksheets that are only for practicing half of the stuff, but I'm a big fan of when you get a picture in front of you that you can use for practice. I'm a really big fan of using it for as much practice as you possibly can. So anytime you have a shape that you get to play with, do everything you know how to do with that shape and get all that practice. So you're going to do an area for every one of these in addition to the circumference. With circles, you are required to know the formulas, as you know if you took geometry. And the circumference formula is diameter times pi. If this is the first time you're seeing geometry, I strongly recommend using the formulas the way I've got them here. So the other formula for circumference is 2 pi r. If your memory of circumference is 2 pi r, you are just headed for disaster, because a 2, a pi, and an r is what the area formula has. So using a formula that is that similar is not a good plan. So instead of 2 pi r, remember it as diameter pi. So 2r is the same thing as d. 2 radiuses would make a diameter. And then area is radius squared pi. I also have, again, just if you're seeing this for the first time and you didn't do the other class, I also put the pi sign at the very end every time. So you probably remember the area formula as pi r squared. To me, that's illogical, because a lot of times you're going to leave the pi sign at the end of the problem in your answer. So if you're going to leave the pi sign at the end anyway, you may as well always visualize that being at the end so that you don't have to rearrange if you do leave pi. What I'm referring to is a lot of times you'll leave pi in the answer and not actually multiply the 3.14. You'll know because they'll either tell you that, or you'll look at the answer choices and you'll see that each one of the answers has pi or doesn't have pi and has a decimal number instead. Very important, when you go to do a circumference or an area, you always want to start by assessing, do I have the right thing? And what I mean by that is, if I'm trying to find a circumference, I want the diameter to be in front of me. Sometimes that's not what I have the radius. You always have both pieces of information, because knowing the radius allows you to know the diameter and vice versa. But you want to look at what's actively in front of you and decide, is this what I want for what I'm trying to find? Or should I begin by filling in what the radius is or what the diameter is? So if you're looking for an area, you are happy if they've got the radius labeled, which is the half. If you're looking for a circumference, you are happy that they have the diameter pointed out, which would be this. This worksheet, you're going to do both. You're doing an area and a circumference. That wouldn't be the case on the test. The test would always have you do one or the other function. So it's up to you with this worksheet. You can either say, I'm going to do circumference first on every single one of these, and I'm going to ask myself this question, or you can decide to do it logically based on what you do have. So I could decide, I'm going to do this one. I'm going to do circumference first because I have the diameter, not the radius. This one, I'm going to do area first because I've got the radius. This one, I've got a diameter, so I'm going to do circumference first. Use one of those two methods, though. Use this to sharpen this skill here. Use your worksheet and how it's formatted to get good at doing that assessment. Either say you're going to do circumference first when you have the right piece of info for that, and area first when you have the right one for that, or say that you're going to change your piece of info to always do a certain one first. So what I'm going to do is I'm just going to do them in order. So I'm going to always do circumference first, since that's what the first blank says. So if I look at number 1 and I'm trying to do a circumference as I need a diameter. I have a diameter, so I don't need to change the info that they've given me for this. So 13 is my diameter. Now with circumference, I'm done really fast, because all I need is to place the diameter number in front of the pi sign, and bim, bam, boom, I'm done. Now, the other way they could answer that, so they could answer it 13 pi, or they could answer as 13 times 3.14, and they could give the actual answer, which is coming out as 40.82. Again, in theory, it won't really come up with circles, but in theory, an area uses a 3-dimensional, 2-dimensional unit, and a perimeter uses a flat unit. They're not going to have that with circles typically. You're not going to see the use of a unit or whatever. But if you do, if they have meters in this case labeled on there, the area would need to be square units or units squared. So the two possible answers for this circumference are 13 pi and 40.82. You're going to know because the answers will either all be decimal numbers, which means they did multiply the pi, or they will all have pi in them, which means that they didn't. They will have you use 3.14 for pi. Don't use the pi button because it will come out a little bit differently. So in these problems, they will actually say 3.14 equals pi. So if they say that, make sure you're using what they're saying is pi, not the pi button. The pi button will round you up a little bit. Now I want to do an area because that's my second blank. Now I'm going to decide, do I have the right thing in front of me for an area? I don't. Areas require radius, not a diameter. All I have to do to get a radius is take the number that's the diameter and divide it by 2. That's going to make my radius 6.5. So half of 13 is 6.5. So that's 6.5 there, and that's 6.5 there. With a area, I'm going to square that, which means to multiply it by itself. There is a squaring button on the calculator. So 6.5 squared equals 42.25. That's a decimal, but remember, we did not multiply pi. We wound up with a decimal because our radius was uneven. So our answer could be 42.25 pi. Or they could end up multiplying pi. So you're going to take times 3.14, and that would make this area 132.67. So your two possible answers there are 42.25 or 132.67. I'll do one more of these and then on to half circles. So let's look at number 2. Pause if you're still trying to write anything or follow anything, because I'm going to erase it to make myself room here. So on number 2, again, I'm going to say I'm doing circumference first, whether it's convenient or not. It's not convenient in this case because my question, do I have the right thing? No. A circumference, we want to have a diameter. We've got a radius. Diameter is radius times 2. So if we had 2 of these, we would have 6 centimeters. And our diameter equals 6 centimeters. So it's very easy to obtain the info you need, but it really helps to ask that question first and make sure you're starting out with the right piece of info. So my diameter is 6 centimeters, which means this could be answered as simply as 6 pi, or they could end up taking the 6 and multiplying that by pi, and that would make it 18.84. Now, when I go to do area, my question, do I have the right piece of info, is answered yes, because I'm going to get rid of the diameter that I was using before and go back to what they gave me. So an area, I do want a radius. This is a radius. So 3 is the radius, and then we want that squared. So 3 times 3 is 9. So you could have 9 pi for this answer, or they could multiply by the pi, by the 3.14, and that would give us 28.26. So that is circles. Keep practicing on circles. Make sure you're asking yourself that question and make sure that you're getting to where you're really efficient with finding what you need to find. There's lots of circle practice on here. I went and drew an entire worksheet of them so that you get tons of practice. That will help you be confident that you've got everything memorized, and it'll help you be fast with getting those problems done, which speed definitely increases confidence. The other thing they could give you with circles is half circles. This is the place where most people struggle in geometry. It's usually either irregular rectangles or it's this. My suggestions in this class are critical if you're having trouble with one of those things. So I told you the best way to figure out the sides, the best way to divide things up and all that with irregulars. That is what makes the difference between someone who understands and does well with that and someone who doesn't. With half circles, it is a matter of understanding what I'm saying about visualization. You must be able to visualize why certain half circles aren't what they appear. This first question says, what is the distance around this shape? Here's the thing about a half circle. There's more in this picture than just half of a circle, because half of a circle looks like that. It doesn't have this. So what they're doing here, the reason it says distance around this shape instead of saying circumference of the half circle is that a half circle circumference would just be this length. So when you find a circumference, you actually are not using that diameter in your final calculation. So if that's an 8-inch diameter, what the 8-inch diameter does, the reason it's in the circumference formula, is it tells us how big the circle is, how wide it is, how much distance it spans. However, when we do circumference, what we end up with is circumference. Circumference is the distance around a circle. This 8 does not end up in your answer. When you get a circumference, this is what you get. So if this is my circumference, then when they say distance around this shape, and the shape has a solid line right here, I've got something extra. So this shape is a half circle with a line that is closing it. That line is not in my circle calculations. I have to manually add that on. So you are going to use your circumference formula. The first thing that you're going to do is you are going to find the circumference. And when you find the circumference, that's going to mean it's really hard to freehand a circle, especially when half of it's already there. So more or less, this is what it looks like. When you find the circumference using that 8-inch diameter, this in pink is what you are finding. So we need to find that, and then we need to cut that in half because we obviously don't want the whole thing. What we want is this. And then we need to add this on. If it helps you to have broad steps that you can place at the beginning of the problem, like with the other things that we do, you're going to do circumference. Then you're going to cut it in half because the circumference will give you a whole circle. You want half. Then you're going to add the diameter on to the number. That's your steps. This only applies to distance around this shape. When it's area inside, it's different. So the circumference of this, we ask ourselves the same question. Do I have the right piece of info to do what I need to do here? So yes, I have a diameter labeled as opposed to a radius. So my circumference is 8 pi. Go ahead and leave pi for now while you're doing your division. So 8 divided by 2 is a lot simpler than getting a decimal and dividing that by 2. So if the circumference of the whole entire circle is 8 pi, then the circumference of this is 4 pi. Now I have to take pi out because I can't add a number in to something that has pi. That would be like adding a 2 to a 2x. They're not like terms. You can't do that. So I can't have a pi sign. So on these, I absolutely have to multiply out. 4 times 3.14 is 12.56. That 12.56, constantly check in with yourself and say, what do I have in front of me? This number that I just found, visually, what does that correspond to? So when I did 8 pi, I had this. When I said divide that by 2 and turn it into 12.56, what I have now is that. So we're closer. We got rid of the whole extra half that we had. Now we've got the distance across this arced section. We take that out of pi terms so that we can add a normal number to it. So we got 12.56, and we're going to add 8 because if we're trying to get the distance from here around and across back to here, we need to add the regular length in there because it's not in there. I know that we used 8 to find the circumference, but that did not mean that the 8 wound up actually in our answer. So we're going to take our 12.56 and add 8, and we're going to get 20.56. So when you're doing distance around a circle, have these steps in mind and understand why. The step everybody has trouble understanding why is the last one. Why are we adding the diameter? If you're having that issue, the reason you're having that issue is because you're convinced that the fact it's here means it wound up in the answer. It didn't. That just tells us how much arc there is that we're dealing with. It doesn't actually put the 8 in. So when we're doing a perimeter, we always want to visualize each step. I'm going to go down a page, and I'm going to do one more of those just to make sure that you get this visual part down. So what is the distance around this shape? This one actually asks us for the distance around and then turns around and asks us for the area, which is what you'll see from that point forward. Always use every half circle I give you and do both. So even on this one that I just did, do an area later for it as well. I will include all of that in the key. So what is the distance around this shape? So what are we going to do? We're going to do the circumference of the whole circle. We're going to have to cut that in half because we don't have a whole circle. We just have half of one. And we're going to add the 10. We're going to add in the straight line that they added to the shape. And that's going to give us the distance across. So what we're trying to do is we're trying to go from here. We parked our car right here. We're going to walk across this rounded path that goes around the pond. We're going to walk across the straight path, and that's going to bring us back to the car. So the first thing I do is circumference, and the first thing I should think about is what am I visually ending up finding when I use this formula? I'm finding this. This is the circumference of a circle. Every circumference that you've ever done, every time you've ever used circumference formula, this is what happens. So do I have the right piece of info to start out with a circumference? Yes, I do. This is diameter. That's what I want. So the circumference of the entire thing is 10 pi. I'm going to make things simple by cutting that in half before I take it out of pi because I don't want the whole circumference. I want that, half of it. So 10 pi divided by 2 is 5 pi. And I'm going to have to take that out of pi because I need to add a normal number to it. So 5 times 3.14 is 15.7. So 15.7 is the distance along this pink part that I have labeled. So I need to add 10 to that. And that's going to allow me to finish walking back to my car by following the last of that path. 15.7 plus 10 is 25.7. So that is the distance around the shape. When you do an area for a half circle, it's much simpler. Remember what an area is. I'm going to go up a couple pages to a normal circle. When I find the circumference, and again, always visualize what you're finding, I'm finding this when I'm finding the circumference. That's why this doesn't end up part of it. When I find an area, I'm finding the space inside. If you haven't recently thought about what area looks like when it's colored in or what perimeter or circumference looks like, that's a really important thing to know. It looks like this. So an area is the space inside a shape, which means it's going to be essentially all of these square units. So when I do the area of a half circle, I actually can basically just use my existing formula because the straight line is not part of it and it's not important. That's an area of a half circle. This is literally just the area of the whole circle, which is going to be this. So the area of an entire circle is all the space inside the circle. I'm going to divide that by 2, and that's going to give me the final answer. The difference is there's not an extra length that's being added in. This is truly asking us for half of an area. It's not asking for half of an area and then something else weird that gets added to it. So if I go back down here, the area of the space inside means that I want to find, I'm going to do this kind of crappy. There shouldn't be any white space at all when you fill in an area, but it takes forever to do it that way. So just ignore that. So what they're asking us to figure out is what is the square unit space taken up here. So again, we have to think about what do we do up at the front before we ever start anything. We want to think about what our steps look like. This time we're going to have our area. So the only formula we know is just the formula that gives us an entire area. That means that at first we're going to get this whole space. So the only way we can do the area of a half circle is to first do the area of a whole circle. Then we're going to cut that in half, and that's it, because when we cut that in half, we're going to get that, and that's what we want. The 10 doesn't really matter. So when we go to find an area, we ask the same question. Do I have the right piece of info? In this case, no. I need to decide that the radius is 5 because the diameter is 10. The radius is the piece of info that I want. So then I enact my formula, area equals radius squared times pi. 5 squared equals 25. So 25 pi is the area of the whole thing. So that's when it still has this other half on it. Then I can just divide that by 2. 25 divided by 2 is 12.5. Remember that that still has pi. So you just divided the 25. You didn't factor in the pi. In the case of an area, whether it's a full circle or a half, they can leave pi in the answer. The only reason you can't leave pi when you're doing distance around is that you have to add something in that doesn't have pi with it. So they could answer this as 12.5 pi, or they could answer it as 12.5 times 3.14, which is 39.25. So these are the 2 possible answers for that. Keep practicing on those. I can't overemphasize how important it is for those to be easy for you. They're not overly common. If you are continuing to struggle with irregular rectangles, or you are continuing to struggle with circles and half circles, at some point you can reevaluate and say, you know what, I continue struggling with this. Do I need those 2 or 3 points? You very likely could just get a backwards area for a rectangle, and that's it for your geometry section. They can ask you anywhere from 0 to 3 questions, and it's reasonably rare that the questions are super hard. Pythagorean, which is what this last page is one of the most common for the harder questions. So if you get geometry on your test, it is likely you will get a certain set of questions about Pythagorean. Rectangles are the most common. So asking you if the area of a certain rectangle is this and its length is that, what's the width? That's the most common. Giving you like a picture of a basketball court and asking for the entire area would be the next most common. And then Pythagorean would be next after that. That would then later be followed by less occurrences of circles, half circles, and irregular rectangles. So if you're doing well with just regular areas and Pythagorean theorem, then you're probably pretty good. You're going to get all, if not most, of your geometry points. If you're really shooting very, very, very high score-wise, you need to get good at circles and irregular rectangles also. Circles, half circles, and irregulars. Pythagorean theorem is only used on right triangles, so there has to be a right angle here for Pythagorean theorem to work. Pythagorean theorem, again, this is review-based, so if I've never taught this to you, this may be too fast. Pythagorean theorem says that a squared plus b squared equals c squared. A and b are the sides, and c is the hypotenuse. The sides are interchangeable. The hypotenuse is not. The hypotenuse must be placed there on its own side of the equal. It doesn't matter if we add a squared plus b squared versus b squared plus a squared. That completely doesn't matter. So the sides are interchangeable. So you always want to identify, am I looking, step one here, am I looking for a hypotenuse or a side? That way you can ensure that you're paying close attention to where you're putting your variable to set up your equation. So am I looking for a side or am I looking for a hypotenuse? When everything is put together, it has to make a true statement. One of the most common questions is one that doesn't give you a picture of a triangle. It says a certain hypotenuse is this. What are its sides? That seems like a very hard question, but it's based on one simple thing. When you take this squared, so we'll call this A, plus that squared, we'll call that B, it equals that squared. So this first one is, for example's sake, 3 squared, I don't know why I wrote 4 there, sorry, 3 squared plus 4 squared should equal 5 squared. If this is a real right triangle and it really exists, adding 3 squared and 4 squared will be the equivalent of 5 squared. 3 squared is 9. 4 squared is 16, 5 squared is 25, and this is true. So you not only need to be able to solve for a missing side, you also need to be able to say whether something is true or not true to determine what the real triangle is. So let's do the second example as looking for a side. So you've got 20 and 15, and I'm going to ask myself, is it the side I'm looking for or the hypotenuse? It is the hypotenuse that is missing. So that means the two pieces that I have are on the same side of the equal sign together. We're going to square each of them and add them together. And that's going to give me c squared, which is the missing side. So 15 times 15 is 225. And then 20 times 20 is 400. So if I add up 225 and 400, that's going to be equivalent to C when it is squared. So 625 equals C squared. The most challenging part of this is this last step. We don't want C squared. We don't write C squared here. We just write C. So we want to unsquare it, which is also known as square rooting it. So we're going to take 625 and you're going to hit the square root button in the calculator, which says something like SQ or SQR. It's something weird that it's not the symbol. It doesn't look like that on the calculator. They did just change the calculator, now that I think of it. They just totally reformatted the calculator on the TEAS. It is possible that it does have the symbol now. You're looking for this and this. So you find that button, you click in the number 625, then you hit the button. So you type in the number, then you hit the square root button. That tells you what the square root of 625 is. And so most of these are going to come out even. They're usually going to let you have an even number that comes out, 625. This calculator does have a square root sign. It's right here. But it could also say SQ or SQR, something like that. There's not a function that has a similar name. So if it looks like they're trying to spell out square root, that's what they're doing. So when I square root 625, I find out that C equals 25. So this triangle is 20, 15, and 25. If you're ever not confident or you just want to double check, you can check your answer. That's a great idea for practicing because it lets you understand this in multiple ways at the same time. So if I have done this right, I should now have a true statement when I fill in all three of the pieces. So 20 squared is 400, 15 squared is 225, 25 squared is 625. That statement, 625 equals 625, is true, so that is correct. Using that right there that I just did, this is the second time that I did one where I filled it in and made it true. That is the skill that the harder questions uses. So down here is an example of one of the harder ones. This one, I have no idea why my computer changed that to hypothesis. That's supposed to be hypotenuse. Sorry. You probably never even would have noticed that, but I will go back and fix it. A right triangle has a hypotenuse of 15. What are the dimensions of its sides? This is where we're using that truth principle. We need to find out, is it true when we plug in this set of numbers, that set of numbers, that set of numbers? There's only going to be one answer that creates a true statement when it's all filled in and everything is squared and we set the sides that are squared equal to the hypotenuse that's squared. Only one combination of numbers that is sitting here is actually going to be a true statement when we fill it in with the 15. The first thing we need to think about is, what is 15 squared? Because that's the number that we're shooting for, and that's going to be 225. So this is essentially a guess and check situation. Although you can be smarter than the problem in a sense by picking a place to start that seems like it could be plausible. It's not plausible that 5 and 6 are going to work, because when you square those two and add them together, that's going to come out less than 100. So those are too small. You may or may not have a set of answers that you feel that you can do that with, but it always pays, as far as time and confidence and heartache and everything else, to try to predict what it's going to look like. Personally, obviously, I think about numbers for a living, so it's a little bit different. I can tell you that A and B are both way too small. So that gives me 9 and 12, or 10 and 12. Let's try 9 and 12. So we're going to plug them into the formula. It's absolutely crucial that you never forget to square something here. So 9 needs to be squared to 81. 12 needs to be squared to 144. Those two do add up to 225. So we wind up with a true statement that 225 equals 225. I will very quickly do D just so you can see. So we know that we're trying to equal out to 225. When we take 10 and we square it, and we take 12 and we square that, we get 100 and 144. That would add to 244, not 225. So when we fill in the final equation with everything done, we have a false statement, and that is how you will prove that 3 of the answers are incorrect. One of them will come out with a true statement, and that's the one that would be correct. So the way they should really ask this question is more so, what could be the dimensions of its sides, rather than what are. There could be many different scenarios that involve a hypotenuse of 15. I think that's why people don't like these questions, is if you really know the Pythagorean theorem, then you know that it's not so simple as, oh, it's these two sides because it's this hypotenuse. It's not that simple. This is just asking, out of these, what are its sides? Because there's only one that's going to work. So that concludes geometry, which means that we have concluded this entire beast of a class. I hope that this was super helpful for reviewing and streamlining your strategies and getting better at everything and just remembering everything. Obviously, there's lots of hours into this video. So some of the feedback that I would like on this, it is October 12th of 2018. So if you are watching this in June of 2019, disregard what I'm about to say, because I must have made a decision to keep it. Right now, this is obviously a brand new recording. What I would like to know is, was it worth all the hours you put in? I don't even know how many hours this adds up to, but it's more than 4 hours of content. Was it worth all those hours to see the different examples and hear the different clarifications? Or should I try to shorten it down to maybe 2 hours, 2.5 hours, 3 hours? I'm not sure how short this actually can get. And that's going to probably depend on your aptitude in math, because if you're terrible at math still, or you're feeling like you are, you probably wanted every example, every clarification, every trick of the trade for remembering things and playing things out. If you're better at math, especially if you're really good at it, this may have been overkill and you may feel like I could have cut lots of examples. So I'm curious to know in the next couple months, the people that see this video over the next couple months from October 12th of 2018 to like end of November 2018, if you're in that time frame, let me know what you think so that I can kind of decide if it's worth trying to re-record, which is a huge pain in the butt, but worth it if you feel like there's too much time involved in this for what you got out of it. So that is it. You have 5 total parts. Obviously, you have tons of practice left in your packet. It's like a 70-page packet. I will have a key completed for it at some point. It's not completed yet. So let me know when you finish this class so that I can send you the key. And that is it. I will see you guys later.